Good evening, students. Today we discuss about the determination of transport number using heat-up method. Uh, this is the fourth video. I hope you already go through the last three video. Uh, this is the determination of transport number using heat-up method. That means in the experimental point of view. So we can first write that determination of transport determination of transport number using heat-up method. Heat-up, HITTORA, heat-up method, using the heat-up method. Is the transport number using heat-up method. We have to first draw a diagram where we do some, in this cases the entire apparatus we have to do. First we have to do, on the left hand side is a cathode compartment. This is the cathode compartment and this is a glass tube and it contains some stopcock. It contains a stopcock in the bottom. This is the cathode part. This is the cathode part, and in this cathode part we have to close this one, leaving some gap. So this gap contains a very narrow glass tube. Very narrow glass tube. Very narrow glass tube. In this glass tube, some mercury is, we have to put some mercury and a platinum or silver electrode. That means a metal. Platinum or silver metal is dipped in it. So it contains, now this is the cathode compartment and you have to remove some portion here and it should contain a U tube. This U tube, there is a U tube and there is a narrow on it. Then a U tube you have to put, and U tube has also a stopcock. U tube also has a stopcock. So this U tube we have to put here. This is the U tube, and this U tube also contain, this is connected with the anode. This is connected with the anode compartment. This is the anode. This is the anode compartment. This anode compartment also has a stopcock at the bottom. Has a stopcock at the bottom. It has some stopcock. So this is connected. This is removed. This is blank space. This is also blank space. In this case, liquid will flow. So this anode compartment also closed, but leaving a small gap for a narrow glass tube. For a narrow glass tube, this is closed. This narrow glass tube contains a silver or platinum wire. At the bottom, mercury is present. It contains some mercury. Then this is the U tube, and this is the cathode compartment. This is the anode compartment. This is the U tube. Both cathode compartment, anode compartment and U tube contain stopcock. Stopcock means it is a tap. When you open it, some liquid will move away. And this cathode compartment, this electrode is the negatively charged electrode and it is connected with a resistance like. Okay, now this anode compartment which contain platinum or silver electrode is connected with a copper colorimeter. Connected with a copper colorimeter. Copper colorimeter is nothing but a container from which we can find out what is the amount. Suppose this is the copper colorimeter and it also contains another part. This is contain copper sulfate and copper anode and cathode both cases. It contain in this way. Then this is connected with a battery from which electric current we have to pass. Then it is connected with a ammeter from which we can measure the current, what is the current you can pass. Then this is connected with a switch which you make on and off. When this is contact with this, then it is on. When it moves, that is a gap, it is off. Now it is connected. It is like a rheostat type. That means if you move this wire, it moves through this, then voltage will change. More and less voltage will occur from this path. And this is ammeter. This is the battery. This is the battery. This is all total for this experiment, and this portion is anode compartment. This is the anode, this is the cathode part. These are stopcock. Stopcock means it is like a tap. It is like a tap. This is also stopcock. When you make on, that means when you open it, some liquids are moved away. This is also stopcock. And this is anode, this is cathode, this is anode, this is called U tube. This electrode is made of either platinum or silver. This electrode also made of through platinum or silver. The concentration of the solution is N/15 silver nitrate. Whatever is the amount of liquid is present inside it, the liquid is present. This is also liquid present here. The same liquid also present in the U tube. Same liquid also present in the U tube. And here the concentration is N/15 silver nitrate. This solution also same concentration N/15 silver nitrate. This solution also same concentration N/15 silver nitrate. Concentration all the cathode, U tube and anode is same. These are called mercury. These are called mercury. This is also called mercury. So this is the mercury. This is the electrode made from platinum or silver. This is also platinum and silver. This entire instrument, this portion is called copper colorimeter or silver colorimeter. This entire portion, suppose I take copper colorimeter, copper COULOMETER, copper colorimeter. It contains copper sulfate. The solution is copper sulfate. This is also one part is copper anode, copper cathode. So this is the copper anode, copper cathode. So this is the entire portion of my instrument. What happens in this case? What we do? Now first you draw this diagram, neat and clean diagram. Then first you write the construction part. The construction part you have to write that in construction part. In the construction part you write that the apparatus consists of three glass tubes. One is the left portion is cathode, right portion is anode, and middle portion is U tube. So both the cathode is connected with a stopcock at the bottom, at anode also is connected with a stopcock at the bottom. U tube also connected with a stopcock at the bottom. This is the construction part, and the cathode contain a narrow glass tube. The anode also contain a narrow glass tube. The narrow glass tube contain mercury at the bottom, and this narrow glass tube also in cathode anode compartment also contain mercury at the bottom. The platinum or silver electrodes are immersed on this mercury. The mercury is present in order to make adequate electrical contact, and the cathode contain N by 15 silver nitrate. Anode also contain N by 15 silver nitrate. The U tube also, this U tube also contain N by 15 silver nitrate. And in this apparatus, the copper colorimeter, this is called copper or silver, whatever you can take. If you take silver colorimeter, you have to take silver nitrate solution. And anode is silver, cathode is also pure silver. In this case, we have to take copper colorimeter, and the solution contain copper sulfate. And anode and cathode both are copper. And important point is that this copper colorimeter is connected in series with this apparatus. This copper colorimeter is connected in series with this apparatus. So this is the construction part. So then after that means in construction part, whatever you draw this one, you have to write. That means the entire apparatus consists of three glass tubes, but it consists of, basically you can write that the entire apparatus consists of four sections. One left portion is cathode made of glass, right portion is anode made of glass, and both cathode and anode connected with the stopcock at the bottom, and both cathode and anode contain a narrow glass tube. The narrow glass tube contain mercury at the bottom, and both the narrow glass tube are contain silver or platinum electrode. Then both cathode and anode are connected with each other through the U tube. This U tube also contains stopcock, and the cathode contain N by 15 silver nitrate. This is also contain N by 15 silver nitrate. The U tube also contain the same concentration of silver nitrate, N by 15 silver nitrate. This is done. The entire apparatus is connected with a colorimeter. This is the fourth section. And in the fourth part, copper colorimeter. In the copper colorimeter is contain electrolyte copper sulfate solution. And anode and cathode both are copper. And cathode is pure copper, anode may be the impure copper, or you can take both are the copper electrodes. Both are the copper electrodes. And in this case, both are, that means anode is copper electrode, pure copper, cathode also pure copper. And these are connected with a battery. And this copper colorimeter, that means the platinum or silver electrode in the anode compartment is connected with a copper colorimeter with anode, and it is connected with the electrolyte copper sulfate, and the cathode is connected with a battery, and this battery is connected with an ammeter. This ammeter is connected with a switch. This is the switch. Switch means if you close it, it is on. Now it is off. Now the switch is connected with a rheostat. That means it is the we can change the potential. And this is the construction part you have to write. Then we have to write discussion part. In the discussion part, you have to write that the middle compartment, then this one, the U tube, this middle compartment or U tube, intermixing both the anode and cathode compartment prevents. That means you have to, in the discussion portion, you have to write that the middle compartment, the middle compartment prevents. The middle compartment prevents, that means this U tube prevents the intermixing of anode and cathode solution. That means this U tube separate the anode and cathode solutions. The middle compartment prevents the intermixing of cathode and anode compartment solutions. Anode compartment solution, it prevents. This is the main aim of the U tube. That means U tube has main aim is that it separate the anode and cathode compartment. Always you remember in heat up method, left portion is cathode, right portion is anode. Otherwise, in case of electrolyte cell or any cell, left portion is anode, right portion is cathode. But using the heat up method, you have to remember just reverse. Left portion is cathode compartment, right portion is anode compartment. Now this is the discussion part. You have to, in these cases, you have to write the what are the properties of U tube. This U tube by middle compartment prevents the intermixing of cathode and anode solutions. The concentration of the silver nitrate, you can write that the concentration of silver nitrate will not change or remain constant during electrolysis. During electrolysis, this silver whatever the concentration means N by 15, whatever the concentration you take in cathode and anode, the same concentration you have to take in the U tube. The concentration of silver nitrate will not change during electrolysis, and after electrolysis it will remain constant. And this is the main aim of the U tube. First thing is that it prevents the intermixing of the cathode and anode compartment solutions. Second portion is that the concentration of silver nitrate should not change during electrolysis, or after electrolysis, whatever with the concentration of silver nitrate, it should be same as that of the initial. If the initial is N by 15 silver nitrate, at the end of the electrolysis also it contains N by 15 silver nitrate. It will not change. And next question is, let us to determine, my aim is let us to determine the transport number of silver. We want to find out the transport number of silver ions in silver nitrate, because we take silver nitrate, so we want to find out the transport number of silver ion. So in order to find out the transport number, whose metal transport number you want to find out, that concentration you have to take in the anode, cathode and U tube. Suppose you have to find out the transport number of copper in copper sulfate, then you have to take copper sulfate solution in anode, copper sulfate solution in cathode and copper sulfate solution in the U tube. If you want to find out suppose iron, transport number of iron 3, then you have to take iron 3 nitrate in the anode, iron 3 nitrate at cathode and iron 3 nitrate in the U tube. And in the copper colorimeter, whatever you take, copper sulfate you will take or silver nitrate you take, if you take silver colorimeter, that does not, whatever you take here, it will not harm here. If you take copper or silver, if instead of copper sulfate, if you take silver nitrate, it will not also harm during this experiment. Okay, let us, we want to find out the transport number of silver ion in silver nitrate. So in order to find out the silver nitrate, in order to determine the transport number, in order to determine the transport number, in order to determine the transport number, we use the platinum and silver electrode. Platinum and silver electrode can be used in order to determine the transport number of silver ion. In order to determine the transport number of silver ion, the platinum and silver electrode can be used. The platinum electrode is not attacked. Attacked means suppose you take platinum electrode, then any material is not deposit on the platinum. Any material, because platinum is a neutral electrode. It does not bear positive or negative charge. Because platinum as a neutral electrode, nothing is deposit on the platinum surface. But that is why the platinum electrode is not attacked. That means platinum electrode is not attacked because platinum is a neutral electrode. But silver electrode is attacked. Silver electrode is attacked because silver electrode is not a neutral electrode. So what happens? Now you may take platinum or silver electrode, but the condition is that platinum electrode is not attacked, but silver electrode is attacked. Then during the electrolysis, after the electrolysis over, the concentration, there is an appreciable change in the concentration around cathode and anode compartment. So during the electrolysis, but after the electrolysis is over, there is a considerable decrease in the concentration of silver nitrate in both cathode and anode compartment. So what do we do? Now in this case, you cannot, that means you should not take you cannot analysis what is the concentration change in cathode and anode compartment. You may take, that means after the electrolysis is over, open the stopcock, remove the solution, and by titration method you have to find out what is the concentration remaining after electrolysis by the titration method. And once the anodic solution you removed and determined by the titration method, there is no need to find out what is the concentration present in the cathode, because you know that the transport number of silver ion in this case plus transport number of nitrate ion should be equal to 1. That means transport number of cation plus transport number of anion is equal to 1. If you find out the anion, then you can automatically find out the transport number of cation. So there is no need to find out, again open it and remove all the solution and by titration method to determine the concentration. There is no need. Only you take any one of the component, any one of the compartment, open the stopcock, any one, not both, any one of the compartment you open the stopcock, remove the solution, by titration method you have to find out what is the concentration change. Then after that what you do, in the next step is you open the stopcock, remove the solution from the U tube and analyze whether its concentration changes or not. The concentration should not change. You should be keep in mind that if the concentration of silver nitrate change in the U tube, in this U tube, then there is a mistake. So just should be keep in mind that you have to open this, remove this solution Then by titration method you find out what is the concentration of silver nitrate. If the concentration should not change, the concentration of the U tube should not change. That should be keep in mind. Now you know that what is the concentration of the anode and what is the concentration of the cathode and what is the concentration of the U tube. This is called in the discussion. Then the working principle is that in the third part is the working principle. In the working principle, what you do now, 10 to 20 milliampere of current in working principle means what you want to do, how is the instrument will work. Working principle, in the working principle what you do now, 10 to 20 milliampere of current, 10 to 20 milliampere of current is passed through the electrolytic solution, through the electrolytic solution for 2 to 3 hours, for 2 to 3 hours. That means 10 to 20 milliampere of current is passed through the electrolytic solution. That means in this apparatus you have to apply 10 to 20 milliampere of current for 2 to 3 hours, and this time is sufficient. So in this time period, there is appreciable change, there is appreciable change in concentration, in both anode and cathode compartment, in both anode and cathode compartment, That means during the 2 to 3 hours of electrolysis, this process is called electrolysis. During the 2 to 3 hours of electrolysis, suppose after 3 hours of electrolysis, the concentration changes very appreciable. Then a significant amount of concentration changes in both cathode and also in anode. Both cathode and anode, there is appreciable change in concentration. So after this also you should be keep in mind that there is no concentration change in the U tube. That means in this U tube you should be keep in mind that there is no change in concentration. So after then there is appreciable change. Then the solution is removed from any one of the compartment. The solution is removed from any one of the compartment, from any one compartment, the solution is removed, and its concentration is determined, using titration method. So using titration method you determine the concentration of any one of the compartment, either anode or cathode, because transport number of cation plus transport number of anion is equal to 1. If you know any one, then you can find out the other. So there is no need to find out the concentration of both compartments. So then in the copper colorimeter, the amount of copper deposited, the amount of copper deposited should be find out. Should be find out. What is the amount of copper deposited? Copper deposited in the cathode. That means the copper is deposited. That means when because this apparatus is connected with a series. That means whatever the electric current pass through it, same current is also passed through this apparatus. So what is the amount of copper deposited in the cathode? You have to find out, and from the amount of copper deposited in the cathode you find out what is the current is passed from the Faraday's law of electrolysis. So what is the amount of copper deposited you have to find out, because it is known that 1 Faraday means 96,500 coulomb of electricity deposit equivalent weight of copper, gram equivalent weight of copper. That means atomic weight of copper is 63.5 gram. This is atomic weight. This is the atomic weight of copper. Valence is 2. So equivalent weight is equal to 63.5 divided by 2. We get 31.75 gram. That means 31.75 gram of copper is equal to 96,500 coulomb. Then from the apparatus you know what is the amount of copper deposited. 1 gram of copper is deposited by 96,500 divided by 31.75 coulomb. Then you have to determine what is the amount of copper deposited. Suppose x gram of copper deposited. That means what is the amount of current is passed. 31.75 into x. This is the coulomb. This amount of current is passed. Coulomb means Q into IT. Coulomb is equal to I into T. That time you know. 2 hour or 3 hour current you pass, but you convert into second. Then coulomb you know. So coulomb is equal to I into T. That means this is the coulomb. That means this one is equivalent to 96,500 divided by 31.75 into x is equal to I into T. Time you convert it into second. 3 hour. Then 3 into 60 you convert it to minute into 60, convert into second, divide, you have to divide this one, you know what is the amount of current is passed. Then from this copper colorimeter you find out what is the amount of current passed through the apparatus. So next is in the next class we do calculations. There are 2 calculations. We have to use both electrodes. First we take platinum, then silver or platinum, any one electrode before electrolysis, after electrolysis. We have 4 calculations are there. In the next class we do. Okay, we will go through this video. I will end here. पढ़ापढ़ी सब कर सबुआडे कोरोना बाहर झारसुगुड़ा ठू आरंभ कर सुंदरगढ़ बाहर बुलबनी गवर्नमेंट बाघ सब छाड़ी आज 200 बाघ आसुँच सब 200 बाघ 103 सिंह आसुँच सब गाँव में छड़ाई तेणु बुलिला माने तो नहीं से पलैब 3-4 दिन है से खाई ना सब गाँव से बुलुवे हल हल बाघ आ सिंह तेणु न पड़े से धरिक पलैबे तुम घर भर जदि पशिज ताहले मध्य धरिक से पलैबे तेणु न पड़े से नहीं पलैबे पढ़ले नेबेनी तेणु पढ़ले से छाड़ी पलैबे तुमको न पढ़ले तुम नहीं खाईदेवे तुम बुलबनी बेसी ओके नेक्स्ट क्लास पढ़ा।